Hello, everybody, and welcome yet again to Frame It Fridays. This is where I show you guys how to frame houses. We're going to take this architectural plan, we're going to do a roof plan, we're going to do a ceiling plan. You're going to have it all figured out, and I'm going to use this scale, these markers, and we are just going to know all about how this house is going to get framed when we're done with this video. So let's get straight into it. This is the roof plan. That's where we're going to put the ceiling plan. So let's start with the roof, because we're going to start from the top and work our way down through the building. Our goal here is to take loads that are up high. They're going to go through various wood members, maybe some beams, maybe some posts. We're going to disperse the load through structural members, and our goal is to get it down into the foundation. That is the point of what we do. So, starting with the roof, what do we care about in the roof? Well, we care about all of the ridges, hips, and valleys. So where are the ridges, hips, and valleys? Okay, well, this is a hip going down that hip. This is a valley, and that's a ridge. This is a tiny ridge. This would be a hip. This would be a hip. This would be a valley. This would be a valley. All right, here's a ridge and a ridge. And there's a tiny ridge right here. So that is, you need to think about these lines as wood members that are currently floating up in the air. Nothing's holding these up unless we put something underneath them to hold them up. So back in the day, we used to be able to frame simple houses and not need to hold these up because we had very simple structures and the ceiling joists held all the walls together in a certain way. But not today. Not today. Not when we build houses like this. So if you got questions, feel free to shoot them in the chat, because I'm going happy to, we're here for learning. So let's go for a quick chat shout out. I see I've got a comment here. Happy Friday, everybody, from Mr. Eugene. Thank you, Eugene. Welcome. Happy Friday, sir. I am glad you're here to learn instead of out there drinking alcohol and wasting time with normies. That's not important. What's important is getting smarter and learning how to solve problems. So let's do it. First thing we're going to do is let's think about our rafters, okay? Our rafters are going to be running in line with the water flow on the roof, right? So they'd be going up and down. I got a marker, so I could use a marker. All right, so they're going to be going like so. I'm not going to draw them all in here, but in this plane, they would do this, in this plane, they would do this. This plane, they would do this. This plane, they would do this. You get the idea. So what we got to do is we're going to pretend they're all there. And we want to think about how far our rafters can run horizontally on our plan before needing to be supported. Well, the rule for that is going to be, we're going to assume a few things. We're going to assume that we're going to use 2x6s, 24 inches on center, and we're going to use Southern Yellow Pine grade number 2. Okay, those are the numbers I'm going to use because that's just a very common material. I build in Texas. This is what we use a lot in Texas. It's fairly, safe to use. So we can go about 11 feet horizontally in our plan before we have to add support to a member. Okay, so what we do is we take our magical scale and we find the 1/4 inch per foot spot, because these are printed 1/4 inch per foot. And look, here's a scale up here. And if I wanted to double check and I put the scale on it, I don't know if you can read this, probably not. But see how the 0 and the 4 and the 8 are lining up with these numbers? That means this is printed to that scale. So I can use this. All right. So I'm going to go from the 0, and I want to see, first of all, how long is my longest rafter? So from the inside support of the wall up to here is 20 feet. That's pretty convenient because that means I can split it in half, and I've got two 10-foot spans on the maximum, and I'm good to go. Or I could go 11 feet in and then put a brace line there. Either way, it's all approximately the same thing. So we're good. So let's do that. Let's just put a brace line in right here, because I know I've got a wall there that I want to use. Same thing on this side. I'll turn the scale this way. That is also 20 feet, which should make sense because that's almost no ridge, which means this building is almost completely square. So I'll do the same thing here. I'll go in about 11 feet is to there. So that's, I would call that a purlin line. All right, that's going to be a member underneath all the rafters, connected to all the rafters with some braces. And that's going to support the weight of the rafters in that line. So on this one, keep in mind, This is a real valley, and this is a real valley. So the rafters in here actually either start from the wall, or they start from one valley and they go into the other valley, or the other hip. Okay, they go in like that. So the longest one in here is actually going to be in the center in here, and he's going to be about 18 feet long. So that is too long. So we're going to want to put something in here somewhere. But because, let's see, about right here and about right here are like good spans. So we don't have to worry about these dudes. So let's just put one in the middle and support, about that middle area. That'll be good there. Let's check from this ridge down to here. That's 10 feet. So these are good. That means, this side's good too, because it's right in the middle. That's 0 to 10 feet. So that means that probably right along this line is where I'm going to want to put one more. And that works out because I got a wall. All right. So this is obviously shorter than 11 feet for these rafters. Okay, so I know my rafters are good. If I do this and I put these bracing lines in, I'm good. I got 2x6s, 24 inches on center. Structurally, I'm sound. So I put the purlins in, but I didn't do anything to hold the purlins up. Okay, right now it's just a little stick thing running hot dog ways. It's running long ways down the framing. So let's add some braces. And I've already got blue rafters. So how about we use orange instead? All right. So we want to brace this dude about every 4 feet. So I would take my scale and I would start on the end. I'd make a circle. The circle means, hey, like if this is my roof and I have this purlin item, the circle is the brace. And this is where we're connecting to the purlin going down to a wall or something, whatever's in there. That's what this circle represents, okay? So circle is where we connect to the roof, and we're going to draw the brace to where we're going to load it, or we're going to put the load. And I don't quite know yet, and this is about 20, so I think this is basically, yeah, that's the right spacing. And put one on the end, put one on the end. It's about 16, so I'm going to stretch them just a little tiny bit. So they're about 14, or about 4 feet. It's good enough. And this is 16, so I'll do these basically right at 4 feet on center, like that. Okay, and this one, same thing. That's basically 12-ish feet. So we'll just do like that. Okay, so now let's look at our bracing dots. If the dot's floating over something that's not solid, it's floating over nothing. So we got to connect it to something. So out here, there's nothing to put it on. So we can't do anything. Right here, we can put the weight on the wall. We can put the weight on the wall, the weight on the wall. Over here. Now it's also, keep in mind, the rafters are slanting. Like if we were to section of this, they're slanting up like this. We want the brace to be sort of perpendicular. If it either can go straight down or it can go perpendicular to like the plane of the roof. You don't want to try bracing back the other direction. It's not ideal, and it's just like a weird connection to make. So you want to try to brace the against the slope. So this one has a wall, has a wall, has a wall. This one doesn't, but hey, maybe we can reach this wall over here. Let's find out if we can. How do we know if we can? Well, in order to reach this wall, we got to know how tall that wall is and how tall the roof is. So here's how we look at that. What's in this plan? Nothing. I happen to be the one designing this actively, so everything's probably 9-foot ceilings. Let's just assume it's all 9-foot ceilings, except for this. We got a raised plate out here and a raised plate out here. And I think I raised the plate all the way down this. And then I adjusted this wall exactly so that this roof plane would die right into that one at the right geometrical location at 9 feet. But this is 9-foot walls on the, oh wait, no, sorry. I raised the whole entry and kitchen area up to 10 feet. That's what this line means in the back. That's a 9-foot plate, slanted ceiling, and then up to 10-foot ceiling right there. All right, so this is all actually 10-foot ceiling, which means this wall is 10 feet tall right in the corner where I need to brace. All right, and this roof plane starts at 9 feet. Important to keep that distinction in mind. So how do we know how high we are right here above 10 feet? Well, we'll start here at 0, and we'll find out how high up the roof are we going. Okay, so we're going up to this line, and these are all at the same height. And that distance is Well, it's a little bit less than 12 feet because we are approaching the 11-foot maximum. So what we're going to do is, since we're a little under 12 feet and our pitch is 812, let's assume we have, like, I don't know, 7 feet we could go, or 6 feet if we're being conservative. Basically, this roof is pretty steep, which means we have a lot of attic space, which means we have a lot of room to reach our braces. So we are certainly going to reach here because that's only about 4 feet. So that's good. Knowing the same thing, I could actually extrapolate that information and be like, well, since these roof planes all start at 9 feet from a 9-foot wall, not this one, this one starts from a 10-foot wall, and we all go in about 11 feet, I have the same reach with all of these, which means I have a lot of reach. So this guy, I'd take and put over here. This guy put on the wall right here. That one's already on a wall. This dude could probably reach over here to this wall. This dude could reach this wall. No sweat. And this dude's pretty high up, so it could probably reach over here and go to that guy. There's no problem with that. And even if it couldn't, I'm gonna need something for the ceiling over here. So I happen to know I'm gonna need a beam somewhere in here because I just got like a big open space. I need something. So we're gonna put a beam in right here. That's our beam. So that beam is gonna be at the ceiling height, flush with the ceiling, so you don't see it when you're in the house. But now we have a load-bearing member to put all this weight on. So we can put our purlins on that if we needed to. Purlin braces can go straight down onto that. Okay. So that's good. Our rafters are now good. So let's take a look at these highlighted ridges, hips, and valleys that we were talking about in the beginning. Rules for ridges, hips, and valleys. We want to brace about 6 to 8 feet on center, down, like, space them 6 to 8 feet, like along the hip or valley. And then we want to try to do 4 feet on a ridge. And that's simply because of the way the loads typically end up being shared. There's generally more weight on a ridge than there is on a hip or valley. Okay, so down here in the corner, what do we got? This corner to here, well, it's a little bit over 8 feet, but I know I'm coming up a little bit, so I'm a little bit steep. And I can push the limit a little bit because I know that I'm right in the corner. There's not a lot of weight building up here yet. So I'm comfortable just taking this guy, bracing it off right there. Now, I need another one. If I go from the brace point up 8 feet, it puts me right here. Well, I'm even higher up now, so I'm happy to brace down to the beam. And I'm going to need another one between these 2 points. So what I could do, yeah, that's 10 feet. Even the beam all the way to here is 10 feet. So I need another one. So what I'm going to do is I'm going to go to 8 feet. I know it's like out here somewhere. And you're going to brace this whole chunk in the center down to the wall. But I've got lots of room. I got lots of height up here. So I'll probably also brace this down to the wall as well. All right, so this guy's good. Let's do this one. This one's easy. Look at this. Look how many walls intersect this thing. You can brace straight down right there. You can brace straight down right there. You can do it right there. You can do it right there. Lots of places to brace that one straight down. Super easy. Same thing right here. Anywhere I see a wall, I can basically brace straight down onto it. So that guy's good. This one, I think I need another beam because I'm not very tall right here, and I'm kind of far away from the wall. So I think I do need another beam. The question is going to be, do I want to go left, right, or front to back? Well, let's look at this. Let's look at the room over here. I don't have any window in the front here, so I could go front to back. I could go right to left. There's really no difference. It's going to come down to which way would I rather run my ceiling joists, and they're probably going to go right to left. And I'd rather put the beam in where I'm in line with the ceiling joists, just so I can not fight them and not use a bunch of metal hardware and stuff. So that's right in the middle underneath that. So that supports this. This guy, I should probably put one brace in here. So I'll brace it here, but I'm high enough that I could probably go right back to this wall. So that one's braced off there. Okay, and that one's fine. This one, look, I got a wall right there, super easy. This joint right here, I've got a wall right there, nice and easy. This dude, okay, wait, this is a ridge, so I gotta do every 4 feet or so. It's basically about 10 feet. So, if I'm being responsible, I'd put one in here and I'd put one in here, get rid of that. This can brace the wall and that can brace the wall because I'm decently high up in the roof. That takes care of that one decently easily. Okay. Now there's this one. Again, we're really high up in the roof. I'll put one in the middle and say, yeah, we're just gonna go over here because I know I'm at least 9 feet up right there, so I can go a few feet. So that takes care of all those. Let's talk about this little guy. What's happening in here? Well, right here, the porch comes out. There's a beam that's like big in the front of this thing. So let's highlight that so we can see what's going on first. So those are beams, and the top of the beam is in line with the 10-foot plate height of the wall, and it comes out and it makes that box. And that's what shapes the start of this roof. But what's happening underneath this one? Well, you could do it a few ways. You could like double or triple up the rafter that runs right here and it like basically make a little beam, or you could put a beam directly below this. That would be another way of doing it. If you just want to keep it super simple, you just put another beam in there. I mean, like when I say beam, it's going to end up being like tiny. Like you could probably use some two 2x6s and that would be structurally sufficient after the math, which I showed you guys how to do the last 2 Fridays. So shout out to that. All right, cool. We're good there. Let's talk about this one. What's going on here? Well, we got to support this. We got to support this mess. Also, I printed this out, so I might as well show you so you guys know what you're looking at. Okay, here's the front. There's that little gable I was talking about. Then there's another one. Rear is showing there's a gable on this side, of course, and then the left. This is a corner lot house, by the way, which is why there's sort of these two gables going front and left. So front this way, left this way, towards the streets. Okay. So those are the elevations. Okay, so what's going on in here? Well, that's a 10-foot plate. So that tells me how high I am if I need to know that. I need to support, let's think about this here. How far is this? 10 feet? 10 feet from wall to ridge. So I should probably put a support in here. And I need to support the ridge in the middle of this anyway. I need at least one support in there. So what I'm going to do is probably should put two in. So put two in, and then I need support for my hips anyway. So I'm just going to run another beam right through here. And one of these braces can go down on the beam like that. Okay. So that beam will catch the support for these valleys. It'll catch the support for the ridge. And this dude could probably, it's not in a great place. And we're not that much higher above it. So we could go back this way. Honestly, if it was me, these beams are at the same height. I'd probably put a brace this way and then I'd put a brace that way. I would double brace that. And then everything would be pretty hunky dory. That's what I would do. Shout out to the Green Observer for coming in the chat, hanging out, learning how we frame things. Welcome. This is a spec home that we're currently in the process of designing. The Green Observer is a secret special designer all on his own as well. All right. So roof is pretty much good to go. We did the purlins, we did the hips, we did the valleys. Nothing crazy going on here. Super simple. Like this is why we keep spec homes simple like this, is because they can just like stack this up pretty darn quick. You don't need a bunch of crazy beams. So let's copy the beams over and look at our ceiling plan. There was a beam right there, and there's a beam about right here. Now you might be thinking, what in the Jesus is going on in the shower? And this is the concept plan. This is in design. So like that's not supposed to be like that. If that was a finished plan, there is certainly no way I would have made that error. And there's extra lines hanging out here, probably from like a 3D solid or something. All right. So roof plan, good to go. Let's talk about the ceiling. Well, let's look at our ceiling joists and think about how we want to do this. I'm thinking if it was me, I got a lot of spaces where right to left would be a good idea. So I think I'm just going to go with like right to left. Generally, like I'm just going to run all my ceiling joists. We'll do this chunk of room with ceiling joists in one chunk. If we're going right to left, I'm going to need a little tiny beam right here, some 2x6s or something, just so I don't run all the way down the hallway. And then I could, and that's kind of a long hallway, so I'd probably just turn the hallway this way. And I've already got like these right here, so I might as well run those down. That's just backing. I could put some short ones in here, put some in here. This guy will just run left or right. Again, this is like super short. That's all backing. This can be short. And then we'll just pick up the right, left again. I don't think they're that long. I don't think they're long enough to do this, but hey, whatever. We just want to keep them simple. All right, so how far are we going across this room? 14 feet? Oh, that's kind of pushing the limit. And this bedroom was fine. This bedroom is 12 feet. These, oh, by the way, 2x6 is 24 inches on center. Southern Yellow Pine number 2 for ceiling loads with no attic storage. Can do 14 feet, about. So that's why I'm actually going to turn these this way in this room so I can use them nice and cheaply. Turn those like that. And then these can just do this, nothing special. And this will be, let's see. Yeah, this should work out. So basically there's going to be a ceiling joist that runs right here. And then I'll pick up and probably change layout and do that one. So like that's probably how I would do that. Oh wait, hold on. Nope. No. This is a beam. This has got to be a beam. All right. So that's a beam. And then I'm going to turn my ceiling joist and go this way. And I'm going to do that because of this line. So this is a 9-foot plate out here. And that's 10-foot ceiling in this space. So if I'm drawing this on the wall, here's my wall. My rafter goes up. And it does that. My ceiling is here. And my 10-foot starts here. So that means my ceiling joists are going to come in here like this, get nailed to my rafters. And they're going to put a block in here like this and nail it to the bottom of the rafters. So there's solid wood supporting it. And that is how they're going to hold the ceiling. Therefore, I want my ceiling joist to be in line with this. And also, that's kind of an annoyingly long span that's closer to 14 feet, and I want to avoid that. So that's a shorter span. That takes care of it. Now, red flag, whenever you see that, it means you're going to load your rafters more than you think you are. The extra ceiling weight from here is being pushed and set on the rafters with this thing. And yes, there's a block sort of also catching the weight, but there's more load going on the rafters than you think. So what does that mean? Right here in this room, these rafters cannot span 11 feet. I made the assumption earlier that they could. Well, what are we at? Well, we're at about 8 feet to our first purlin support. So if I was, I'm actually not that worried about it because like 8 feet's pretty good. That's a solid, 60 or 70% of 11. So yeah, I mean, that's like actually pretty reasonable for the little bit of extra weight. And this is not that big of a room. So there's a bunch of math and like factors and stuff you can do to find out the exact numbers, but you want to keep in mind every time you see that red flag that you got to be aware of the span. So these guys would be pretty simple. We'd run them right to left, just like this. And then the patio, let's look at the roof. What's the roof doing? Well, it could go either way. So we'll just do this. All right. And let's look in here at these ceiling joists. They're going farther than 14 feet. So let's throw in a little 2x6 beam, whatever, something right there, just to break the span. And that's pretty good. Okay. So we got a beam here, here, and then over here. And for the first time, I think on the Frame It Fridays, we actually are introducing a hanger. There's actually going to be a hanger, folks. Okay. Between these beams right here. So, and honestly, here's an interesting detail. I think the way I put this, where this wall ended, if I was framing this, I would stretch the wall a little bit so I get enough bearing for this beam and this beam. But let's say in the situation where I only had the wall and the wall ended and my beam was like right on the end of the wall, and I also had to hang this beam. Well, what would I do? Here's what I'd probably do. There's multiple ways to do this. Okay, so let's look top down and imagine this scenario right down here. So top down, here is the wall framing. It stops, goes this way. And that beam's probably going to be some LVL or something. So let's say it's 2 plies of LVL. Okay, so there's your beam and it lands on the end of the wall. So what's going to happen, and I have another beam that's also 2 plies of LVL, which would be ridiculous for that size. It's probably not. But that's the situation I have. How do I hold up this beam if I have no wall left? The only way to do that is by using a hanger. Okay, so if I do this, I've got a hanger. Now, I would have to use a concealed flange hanger to do this because I don't have any wood over here. If when I install this beam, I cut it right to the length of the wall. But most people don't cut the beam short if they don't have to, because that's just extra work. They'll just run the beams long and let it sit up in the attic, and no one's ever going to care. So if I have like the beam running long, I could actually use a face-mounted hanger, and the flanges come out to this side, and then they get nailed in like this. So you wouldn't have to nail inside here. You would just do it on the outsides if you have extra wood. But you got to think about that while you're framing this. So yeah, a little hanger right there, maybe a little hanger right here. You'd of course want to check loads, check your numbers, make sure your hangers are sufficient. All this, that, and the other probably is because there's almost no weight here. In fact, it definitely is because there's basically nothing. Wait. Oh, excuse me. You can tell it's getting close to my bedtime, folks. 7:56 over here in Texas, and I go to bed at 8 usually. All right, what else do we got? We got the ceiling joists. We got the beams in here. We can't forget about the headers. That's right, folks. Every single opening is a place where we are displacing the load. Remember, here's the load. Load comes down. This would be an example. Hey, here's a header. I took load and I spread it out and I made an opening that people can walk through. Look at that. People can walk through the opening. How happy. Happy people. All right, so everywhere there's a doorway or a window, there's a header. Generally, I would define a header as inside a wall assembly, like it's built into the wall. When you like raise the wall, you're putting the header in the wall. And generally, I would describe a beam as something that sits on a wall. That's generally the lingo I would use if I was being picky. Or just I wanted to be consistent and describe the same thing to people. There's a big header above the garage doors. You got to watch out for those. We got to watch out sometimes for those super wide double garage doors. I've seen architects and designers take these doors that are massive and they'll say like, hey, wall plate height. Let me draw this out so you guys can learn something from this. Because we're pretty much done here. It's all taken care of. I didn't put any attic access in here, but like maybe it would be in here. So let's flip this over. Actually, let's flip both of these over. Nice white sheet. Okay, so I forgot what I was talking about entirely. Oh, garage headers. Okay, so if this is a front, this is like an elevation shot. Wait, I wonder if I could use the elevation shot. How about that? How about that, folks? Okay, so elevation shot. For example, let's assume this is there's just some crazy amount of weight on this garage door, or the garage door is super wide or whatever. And for whatever reason, we need like an 18-inch tall or a 24-inch tall like LVL header over this garage door. What people forget sometimes is that the garage header height has to be a certain height. If this is an 8-foot door, that means from the bottom of the garage floor, which has been sloped, right? See the door drops. Garage to here, let's say that's 8 feet. Architects or designers will sometimes say, yeah, my roof is designed to start. And like, it wouldn't matter here because I have a gable wall, I could push the beam up. But if I didn't, then my header exists, about right here. So if my header needs to be 2 feet tall, the bottom of the header needs to be at 8 feet. Guess what that means? The top of the header is at 10 feet. Some designers will design houses and be like, oh yeah, the plate height was 9 feet for the roof to start at, like down here. And then they go to build this thing and the framers are like, dude, what are we going to do? This header doesn't fit. And I have been an engineer called by the builder because he's like, dude, like the beam you spec'd, like, and it's not like necessarily a fault thing. It's like the architect or designer was not aware of structural requirements, and the engineers were not responsible for the fact that the architect said, hey, your roof does this. Now, most of the time, the engineer tries to catch something like this and call someone and say, hey, that's a bad, like that needs to change. That will be a problem because I'm speccing this beam size and it's not going to fit. do something about it. So that's the thing that can happen. So just be aware, watch out for those big garage door headers, and like leave ample space above them with plate heights and stuff like that, so you don't screw yourself or anyone else. Folks, I think that's all I've got. That is the framing layout with markers on this plan. I hope this has been helpful to you guys, and I will see y'all in the next one. Thanks for coming in. Shout out to Eugene and Green Observer for chatting it up. You guys have a great weekend, and let's get ahead of everybody else this weekend. Let's do that. And of course, let's take it out by the one and only. Look, he's in the chat today. The Green Observer. That's right. He wrote this music right here. Let's take it out.
That's the code.